right, let's solve some log and exponential equations. So looking at these first examples here, we might notice we've got log base 3 and log base 3 on each side. In example C, we have ln and ln, the natural log on each side. So if we have equations with the same log and the same base on each side, we can just cancel those. And then we're just left with what is inside the function. So we've got 5x minus 1 equals x plus 7. So it looked like a complicated equation is now become much simpler because those log functions cancel. So now we just follow our normal steps for solving a multi-step equation. I get 4x equals 8, and dividing by 4, I find that x equals 2. If we look at this other example, again, because of that natural log and the natural log on each side, I can cancel those. So I'm left with 2x plus 1 equals x minus 1. And then I can solve for x, and I get x equals negative 2. So when we have the same log function on each side, we can cancel them. Okay, if I look at examples B and D, I see I've got a log here, but there's no log on this side. So unfortunately, I can't use that strategy. But because we only have one log, we can use the snail method to help us rewrite it as an exponent. So we want to rewrite as an exponent, because that is going to allow us to get rid of this log. So I see my base of 5 is raised to the second power. 5 to the second power equals all of this stuff on the inside. Well, now the log is gone, and so I can just simplify the exponent and solve. So 5 squared equals 25. 25 equals 3x plus 1. And now I just need to follow the steps. 24 equals 3x. Divide it by 3, and I get that 8 equals x. If I look at example D, I notice the same problem. I've got natural log, and then I've got nothing on the right side in terms of a log. And we need to remember that when there's no base on a natural log, it's always e. So I'm going to use my snail method again and say e raised to the 0 power equals all of this stuff on the inside, 3x plus 1. Well, e is a number, it's close to 2.71, but raised to the 0, anything raised to the 0 power just equals 1. So now I have 1 equals 3x plus 1, and if I subtract, I get 0 equals 3x, and so x just equals 0. So these are the different types of functions the different types of equations we might encounter that have log functions. We also might have equations that don't have logs, but they have exponents. And instead of exponents being numbers like we're used to, we can see in all of these that the exponents have variables. So we need to use a different strategy to help us with these. So when solving equations with exponents, if we can get the base to be the same, so like if we know that these are the same and the base is both x, then a must equal b as well. So we want to make the bases the same. So if we look at the first example, we have e and we have e as our bases. Those are already the same, so we can cancel the bases, and we're just left with x equals 2x plus 7. Well, solving this, we get negative x equals 7, or if you divide that by negative 1, we find that x equals negative 7. But when we look at this middle example, I see my base is 10 and then my base is 100. So unfortunately, I can't cancel the bases right away, but I can use this strategy to make the bases the same. If I think about 100, I know that 10 squared equals 100. So I'm going to rewrite this 100 as 10 squared. So I copied on the left side, 10 to x minus 3 equals 10 squared, and then I need to bring this down in parentheses, 4x minus 5. Now that these bases are the same, I can cancel those 10s, and I'm left with x minus 3 equals 2 times 4x minus 5. Now I just need to solve for x, so I start by distributing. Get x minus 3 equals 8x minus 10. And then just go through a couple steps and we can find that 7 equals 7x, meaning that 1 equals x. All right, let's try one more. So in that middle example, we only had to change one of the bases. But in this one, we notice we've got 4 and 8. And if you think about it, 4 squared makes 16. So I'm not going to be able to change the 8 into a 4. But I know that both 4 and 8 have 2 in common. So I could make the, here, let me change marker colors so we can see it better. I could rewrite this 4 as a 2 squared, and I could rewrite the 8 as a 2 cubed. So I'm going to take these pieces to rewrite. So I'm rewriting 4 as 2 squared and bringing the 3x down in parentheses equals this 8 is becoming 2 cubed and bringing down that x plus 1 in parentheses. So even though we had to rewrite both bases, now they're both 2, so we can cancel, and we get that 2 times 3x equals 3 times x plus 1. So now we just need to do some algebra, distribute this right side, and we get 3x equals 3. Dividing by 3, again, we happen to get x equals 1. Great job!